This is a video demo for GIS 311, what is currently Lab 6, using census data. We're going to have a scenario regarding a potential interview question from a boss if you're in an interview for a job position. The details of which can be found in the Quiz 6 directions that are available within Canvas. But imagine for a moment that you've been selected for a final round of interviews for your ideal job, paying at least $55,000 to start in your desired city or state. The final round of interviews begins with a short GIS task that has been perplexing your boss. They'd like to hire somebody that knows how to obtain and utilize cartographic, there being shapefiles and feature classes, and demographic, think of text or database files, Excel files, from the U.S. Census, and explain the following items. There are many sources of boundaries on the census.gov website, but what is the difference? Aren't boundary lines boundary lines? And how do we choose the correct files for a particular situation? In this scenario and during the quiz, I will explain the difference between various types, sizes, resolutions of cartographic data options on the census.gov website, along with how to utilize portions of the demographic data that doesn't appear to be related to the boundaries. In order to answer the interview question, I will download demographic tables of non-spatial data and cartographic spatial data from the U.S. Census to compare three nation-based cartography files with 500, 5 million, and 20 million resolution, along with some state-based 500,000 resolution files, as well as some TIGER, which stands for Topically Integrated Geographic Encoding and Referencing files. I'll then visualize them in one map to help explain and show them to a potential boss during an interview. At the same time, I'm going to create a map that will serve as a reference for future GIS work and Lab 6. In short, I'm going to set up a working directory to help with the explanation/mock interview, remembering all the required steps. I'm going to view some cartographic boundary files at the census.gov and explain the differences between the items available. I'm going to download some geographic files, each to their own individual folders within my raw data. Nation-based files, and they're listed in front of you. Nation-based state files, state-based county subdivision files, and census tract files. I am then going to create a visual demonstrating the differences in resolution between the cartographic boundary files using the native geographic coordinate system of the downloaded data. I am then going to download demographic data files into an individual folder within my raw data. Specifically, I'm going to be locating some household type demographics so that later I can create a choropleth map to represent the percentage of 2010 Washington households that had a male householder with no wife present. That is in step 5. I will then download topically integrated geographic encoding and referencing geographic shapefiles. Those are the TIGER files. And select a good projection with which to display the polygons. I'm going to import the demographic data into Excel and prepare it for use in GIS by deleting restricted characters, removing multiple header rows if present, and creating a Use My Data Excel file. And this is what I refer to as an ArcGIS worthy worksheet. I will then join the demographic data to the TIGER shapefiles and symbolize the percentage of 2010 households that had a male householder with no wife present. And the last item is, if students were completing this in class, I'm asking you to symbolize your layers so that the interview will not remind your future boss of Easter. That is, no pastels. It should be noted that this is not an easy task the first time around, but it gets easier with practice. And I would like to remind you that what is stated here, we don't grow when things are easy, we grow when we face challenges. This will be a learning process, how to navigate the census website, which is actually always changing. We just have to face the challenges and get through the issues. The first step is to download and the first step is to prepare a directory and prepare ArcMap. I've completed step 1. I've saved my blank map in ArcMap. I've changed my data frame name. My map is here in my maps. I have no data in my data, no data in my raw data. I have my Quiz 6 and my user ID Quiz 6. In terms of geoprocessing options, I have turned off background processing by unchecking. I've gone to map document properties and notice that I have not clicked store relative path names. I need to do that. And then once again back to geoprocessing and environments. I set one of my workspaces but not the second. So I will set the Scratch workspace right now by clicking on my data, using this drop down to make sure I'm in my 311 directory for winter 2020. In my quizzes, Quiz 6, user ID folder, click once on data and add, and it's in the right spot. I will not be setting my output coordinates yet, but I will likely set it later. And as of now, these are all the settings that we need to set here in environment settings. I've navigated to census.gov and will now try to find the data that we're looking for in this quiz, and you'll be finding in the lab. First step to finding data on the US Census is to grab the shapefiles. I'm going to look for or search in the search bar for cartographic boundary files. In the search results, cartographic boundary file shapefile, and it pulls up a list of different shapefiles, and this is where we're going to download our data. I'm going to shift to 2010 just to keep things simple. It should be noted that you will not need all of the files that I'm about to download for your lab. You'll be downloading some files, but not the bunch that we're about to do right now. This is for demonstration purposes and to give you a viewing of how I download and save files. The first items I'm going to look for are nation-based county files for 2010. I'm looking for nation-based, here's national, county files, and the first one I want is 500,000, 500K resolution. I right click, open in a new tab, and I get this download. Mine will look like a zip, yours may or may not. I'm going to save that, navigate to my 2020 directory, my 311 2020 directory, in quizzes, Quiz 6, in raw data. Before I download the data, I'm quickly going to add a new folder and name the folder exactly as the data I'm downloading so that I don't get confused. So this is Census 2010 Nation-Based County 500K. And save it within that folder. The next item I'm looking for is nation-based county files 5 million resolution, which is this zip file. Click on it, save file, create a new folder for it, and save the file. The third one from this area will be nation-based county files, 20 million resolution. Open my new folder and save. The data I've downloaded is nation-based county files. So the data is all of the counties for the entire nation. The next data I'm going to download is nation-based state files. That is all the states for the entire nation. Scroll down. Here's nation, state. Nation-based states. Now here's my 500K file. Go back to my raw data and create a new folder. Census 2010 nation based state 500,000 resolution, and we'll talk about that later. Nation based state, save. The next is nation based states, 5 million. And the last is the 20 million. I have now successfully downloaded 6 different files into 6 separate folders. The next step is to find state-based county subdivision files. That is, for Washington State, I want county subdivision. So state-based county files. Here's county subdivisions. Notice it's listed under the state. And the state I would like is Washington. Click OK. Put this in a new folder. Census 2010 state-based county subdivision 500K. I know it's 500K because the 500K in the file name. Save. This is a repeat. I'm going to cancel. I then want census tract files for all of Washington State. Census tracts, as you read in the reading, are subdivisions of counties. Scroll to Washington, save the file in a new folder. Census 2010 state-based census tracts. Notice it's not TRACK. The resolution is 500K as noted in the file name. Census tracts, save. The third one from this area are block group files for all of Washington State. Block groups are subdivision of county tracts, which are subdivisions of counties. Under block groups, go to Washington, save the file in a new folder within my raw data, Census 2010. These are still state-based, block, group, and again it's 500,000 resolution, 500K. I have now downloaded the files listed in step 3. The next step, step 4, is to create a visual demonstrating the differences in resolution between the cartographic boundary files that we downloaded in step 3, using the native geographic coordinate system of the downloaded data. The first step to doing so is to extract all of these files. I'll do that. I'll pause the video and do that on my own. I've completed downloading the data and extracting it. I will refresh my raw data and open up all my raw data so you can see it. There's all my raw data. And understand how complicated this would be if I didn't have folders telling me what was in each file. First items I'm going to compare are the county-based files. I'll bring each of these into the map. I will do all 3 before I clear the projection because I know I'm just dropping these in. Now that I've loaded them all, I'm going to clear the projection of my data frame. Notice that the native coordinate system is Geographic Coordinate System, North America, 1983. I'll zoom into Washington State. Remember, these are nation-based files, so they were the whole nation. If I go back, first I'm going to create a bookmark for Washington. I'll go back to the nation. They're very large files because it's in the entire nation. And again, it is county data. Zoom back to Washington. I'm going to zoom particularly into the Puget Sound region. This is Tacoma, and don't be thrown off by the way this looks. It's because it's a geographic coordinate system. And the way the layers are organized in my data frame right now will allow me to look at the data. By modifying them just slightly, by putting the smaller, the 500K resolution, then the 5 million, then the 20 million, it'll be easier to see. And I'm going to change the coloring, the symbology, so that's very easy to see. Orange, blue. If I have just the 20 million resolution, that means that this data is best viewed at 20 million. And right now I'm at 1 to 675,000. So if I change that to 1 million, it looks a little bit better. But changing it to 3 million will make the data look a lot better. However, if I go to the 5 million, well, let's try going up to 20. Well, here's 1 to 10. That looks pretty good. Notice the Puget Sound isn't that muddled. If I turn on the 5 million, all of the lines in this general area, because of how small the view is, all the lines of the Puget Sound are running together. And it gets even worse if I add the red data, being the 500,000 resolution data. this data is built for 500,000, whereas right now we're at 1 to 10 million. So ideally, this is best viewed at 1 to 20 million, this is best viewed at 1 to 5 million, and this is best viewed at 1 to 500,000. So I'm going to set those into my map scale by customizing the list. I'm going to put in 500,000. The reason it was dinging at me was there's already 1 to 500,000. So let's try 5 million. $5 million has been added, and let's add 20 million. Now that they're all added, 20 million, 5 million, 500,000, I'll click OK. So 500,000 is where that is best used for. This is 500,000. And notice, with the other layers turned off, much more the Puget Sound can show. This white area is Puget Sound. If I zoom to 1 to 5 million, this isn't the best for viewing because the lines of the features themselves start to crowd. Thus, the 1 to 5 million is much more accurate for 1 to 500 viewing. And last but not least, we notice how many lines get taken away, or how much water gets taken away when we switch to 20 million. And that's simply because of the best viewing possible. We'll go to 1 to 20. And again, back here with the 1 to 500,000, it does not work at this 20 million resolution. To make things easier, I'm going to change the name of my data frame to county-based. I'm going to insert a new data frame, rename it state-based. I don't really need the underscore. Take it out of here before I forget. I will now add the state-based files. State-based 20 million, state-based 500,000. They're ordered alphabetically. State-based 5 million. Organize them with 500,000 on top, then 5 million, then 20 million. I'm going to symbolize these. I've symbolized. I'll now zoom into Washington. My bookmarks, of course, don't work because I built them in the other data frame. Let's go to 1 to 500,000. This is the viewing resolution that is best for 500,000. 1 to 500,000, you can see how the 1 to 500,000 works. If I go to 1 to 5 million, which isn't in the list, so I have to customize it again. I'll add 20 million. The borders are starting to muddy up the water, but here with the magenta, it's a little bit easier to see. Notice how a little bit of the water gets taken away, especially the muddied up portions. And then at 20 million, lots of dark gray of the borders, minimal, a little bit less dark gray, whereas this is pretty good. It's still pretty blurred. This would be better viewed at about 1 to 6 million. And there we have a comparison of state-based files. And again, this is state-based, so these are only states. If I were to look at any of these, I'll just show one. all that is listed are the states. For the county-based, once I activate and look at any one of them, each of the counties for each of the states. Now realize there are 3,221 different counties in all of the states. So this is all the counties in the entire country. And notice, zoom out this far, it's a bunch of borders. That's all we see. We don't really see the red. This is a good example. The bigger counties out in the west aren't as cluttered as all the counties towards the east, where they're a lot smaller. The last demonstration with the remaining 3 files that I've downloaded of this, the initial download, in my new data frame. I'm going to call this state-based other, because these are all 3 different files that we're looking at. They're not all the same. And bring them all in. And remember, they're only for Washington State. Clear the projection because I just added files. I will now re-symbolize these. In this case, they're all built for 500,000 resolution. Let's zoom to 1 to 500,000. I'll zoom over to the to the Puget Sound. I'm going to change the border a little bit so it's easier to see. Maybe a white will make it easier. These are block groups. Notice how small they are. The next size up, there are a little bit fewer number of these. Let me change the border again to white. These are a little bit bigger. There are a certain number of block groups within each census tract. The census tract combine to form county subdivisions, and these are the county subdivisions. These are a little bit tricky in the lab. I'll talk about them a little bit more. But if we go to the attribute table, each of the counties has a number. If I sort ascending and select all the ones, for example, and then zoom to and minimize or close the window, this is one of the counties. It's a county made up of 3 different county subdivisions. Our county is 53, which makes it easier. I'm going to deselect, search for county 53, because that's our county number for Pierce. Highlight all of them, close the window, zoom back out, go to Pierce County, and notice there are a number of county subdivisions within Pierce County. This shows just the different delineations between block group, census tract, and county subdivision. Whereas up here, that we're county based, if I activate and then zoom to Pierce County, I'll be able to see Pierce County right there. It's the same shape as down here, although this is delineated by county. And of course, state-based are just states. I should change the border so it's easier to see. And that's the state. So I can't do anything with Pierce County in this area. It's just the state. There's one line for the state in the data. If I open the attribute table, scroll down to Washington, well, I guess it's not alphabetical yet. Now it is. Washington is now highlighted. we have just completed, or I have just completed step 4, which is approximately half of quiz 6. I'm going to stop the video here. It's about 30 minutes. There will be a separate video for steps 5, 6, 7, and 8 of quiz 6.